So hello, my name is Shoaib Mustafa Ali, and me and my team are assigned the buffer tree data structure for our group project. So firstly we say there is the introduction of buffer tree. So firstly we start off by choosing certain parameters according to our IO model, which are A A being the element in the problem instance, and B will be the element per block, and C is the element that can fit in the internal memory. Now moving forward, we'll discuss what buffer tree basically is. So buffer tree is a data structure where every internal node has a degree of O of x, where x equals to C upon B. And here C upon B means that the number of blocks that can fit into the internal memory. Now moving forward, so buffer tree is mostly similar to the binary tree, so the searching and functionality of both of them is same. But the difference in buffer tree is that it uses buffers, which optimizes the memory, and better timing efficiency is achieved as compared to binary tree. So, moreover, buffer tree's basic structure consists of an internal and external memory, and buffers are used in both memory to select the operation, and you can see that in the diagram mentioned below.
Basically, the first two articles mentioned here are the ones that we have researched till now. These two articles give a good intuition as to why buffer trees should be used, why buffer trees are more efficient and more optimal than other data structures. It also describes some of the limitations that buffer trees have and how buffer trees actually use external and internal memory together to optimize memory and result in memory optimization, which results in memory optimization. It also describes in detail how buffer trees are constructed, how nodes are entered, and how some basic processing operations are performed on buffer trees like search and insert, and how basically buffer tree works, how internal and external memories are used together in buffer trees, how buffer trees save operations by first buffering them and then processing them in batches. So these two gives a clear understanding of why buffer trees, what is the context as to why buffer trees are used and preferred over other data structures, and also discuss and compare the complexities, and then how buffer trees are constructed and the basic dynamics of buffer tree. The third article mentioned here is basically a presentation that we intend to look into in the future as to see some of the applications to work on in the buffer trees. Some of the applications mentioned here. So yeah, that's it.
So moving on to the problem, uh, buffer trees by design can be used to solve dynamic batch problems efficiently, such as line sweeping, and in a lot of cases they can be much more efficient than some other methods that could be used for sorting. So we think we could implement them in some maybe navigation systems or just use it for data optimization. As Shoaib explained earlier, the buffer trees operations. So we think that we can achieve a time complexity of O n log m n, where basically m will be the base of the size of the buffer that is attached to each node, and then we can also use this in a priority queue where the buffer tree can basically be uh, used in the external memory by permitting update operation into the priority queue and adding an extra function that will delete the smallest element in the tree. So what this does is that it ensures that we're reducing our amortized cost. So this leads to us having a very efficient sorting system.
So as for teamwork, we have divided our work into three deliverables and we will be working closely together for each of it and try to complete the project successfully.
So these are basically the deliverables that we have planned. By the end of this week, we intend to strengthen our research on the application and also identify some of the operations required for this data structure. And then the coming week from 19th to 25th April, the next week, we will be working on different functions that are required in the data structure and the application and test them that whether they are running all right or not. And then the week after that, which is from 26th April to 2nd May, we'll integrate all the functions that we have created and then also check that if the desired output and the desired result is there for us, and also prepare our final poster and the final presentation for the project. So that is how we intend to approach this.